In the previous episode, we discussed Azure Virtual Networks or Vnet in great detail. In case if you missed that episode or if you need a quick refresher, let's go over it really quick. So Vnet or virtual network provides network isolation through segmentation. So let's say we have a prefix of 10.1.2.0.16. Then we can use that to create our Vnet. And within that, then we can further isolate that into smaller subnets. And then we can start installing VMs or other things that we need within those subnets. We can also provide services such as DNS within our Vnet. Again, remember, this Vnet is an island right now. It doesn't have any connectivity to anything else. So we can provide DNS connectivity or service within the Vnet itself. We can also create assets such as VMs, and then we can use any of these subnets to get an IP address from that. Let's say we get an IP address from this subnet, and then we get the IP address from that subnet, and then we can also then register that in that DNS. So now we have this VM that is registered, and we have other VMs that we created, and we can provide name resolution among all of them. Let's say now we want to have access to this from our home network or from our work network. And we don't want to create public IP addresses for our VMs and other assets. So the way to do that is to set up a VPN gateway. That provides full access from our home network or from our data center to that Vnet. We can also use Bastion hosts. So Bastion hosts, we can only access VMs from the outside world. Let's say we create another Vnet. This one is Vnet 2. We use a different prefix like 10.2.00/16, and again we can divide it into a smaller subnet, and then we can also again start assets such as VMs within this Vnet. But again, these two are completely separated. If we need to provide connectivity between these two, Azure provides a service called peering that then provides access, so it creates appropriate routes that from this Vnet to the other Vnet. And this really works well for smaller, if you have small number of Vnets. However, as the number grows, then it becomes more really difficult to manually create and manage those. Also, if you want to apply network security or configuration, then you can have to do it manually, do it on each Vnet. And that's where Azure Virtual Network Manager come into place. It kind of automate a lot of stuff. Azure Network Virtual Manager, or AVNM for short, is a centralized network management service in Azure that allows organizations to control, secure, and automate networking across multiple virtual networks, or VNets, at scale. It helps in managing connectivity, enforcing security policies, and simplifying network configuration across such subscriptions and regions. Some of the key features: centralized network topology management. It supports two types of topology, hub and sub, and mesh. We'll be talking about those in detail a little bit later. Security policy enforcement across VNets, automated network configuration using network groups, cross-region and cross-subscription management, integration with Azure Firewall and Virtual WAN for advanced security. Some of the components of Azure Virtual Network Manager. The first one is network groups, logical groupings of VNets that allow centralized management. VNets can be added manually or dynamically based on tags, naming conventions, or subscription location. Connectivity configurations. defines how VNets communicate with each other, supports two topologies, as mentioned earlier, hub and spoke. All VNets communicate via a centralized hub, or mesh. All VNets in the group can communicate directly. It also has security admin configurations. AVNM, or Azure Virtual Network Manager, supports security admin rules to enforce security policies across VNets at scale. I'll be talking about security, VNet security, in a different video. Network topology in Azure refers to the structure and arrangements of Azure virtual networks, or VNets, and their interconnections, which define how network resources communicate with each other. In Azure, network topologies are critical for ensuring efficient communication, security, and scalability. VNets can be connected to each other via virtual network peering, to on-premise networks via VPN gateways or express route, and can integrate with services like Azure Firewall or third-party network virtual appliances for advanced routings and security. AVNM supports two primary network topologies within its connectivity configurations: hub and spoke, and mesh. These topologies can be customized with additional settings like direct connectivity between spokes or global mesh. We'll be talking about those a little bit later. In a hub and spoke topology, a central hub VNet acts as a connectivity and control point, connecting to multiple spoke VNets. The hub typically hosts shared services, for example, Azure Firewall, VPN gateways, or NVS, while spoke isolate individual workloads or environments, for example, production versus development. In a mesh topology, VNets within a network group are fully interconnected, allowing direct communication between each pair of VNets without requiring an intermediary hub. Every VNet in the mesh is paired with every other VNet, creating a fully connected network graph. This ensures low latency direct communication paths between all VNets in the group. This is an illustration of a hub and spoke topology. So this VNet acts as a hub and the rest act as a spoke. So when we set this up through Virtual Network Manager, then hub will have direct communication with each and every one of those spokes. And the hub becomes an entry point into the other environments. For instance, if we have applications that are running in spokes that need to be accessed from outside our environment, outside the virtual network environment, then we can set up a firewall here and then use firewall and routing to route the traffic to the spokes. In this case, and in that sense, then we have more control of who and what is coming into our environment. We can also set up other services such as DNS and provide name resolution for all the spokes in the environment. So by default, there is no one spoke-to-spoke communication. So this is typical hub and spoke topology. However, AVNM allows creating what is known as connected group. That is, we'll be able to, if we need to, we can set up direct communication between spokes if needed. For instance, let's say spoke 1 and spoke 2. These are our production environment and they have dependency on each other. And these two are, let's say, the dev or staging environment, and we don't want these to be connected to the production environment. So what we could do is we could set up a connected group here, and then we can directly connect spoke 1 to spoke 2. Also, if we need, let's say from on-prem, we need to communicate with the hub and spokes, we can set up a VPN gateway in the hub environment and then share that to be able to then connect to other spokes through that VPN gateway. And that is a setting that we can set, and we'll go through that during the demo. A mesh topology connects all VNets within a network group directly to each other, forming a fully interconnected network. This eliminates the need for a central hub, allowing bi-directional traffic between all participating VNets as described here. You can see all of the spokes are directly, all the VNets are directly connected to each other. There's no hub here. By default, mesh connectivity is limited to VNets within the same Azure region. However, we can enable global mesh, and then by doing so, then these VNets can be in different geographic, Azure geographic location. Use cases best suited for scenarios requiring low latency communication between all VNets, such as distributed applications or peer-to-peer workloads. For instance, a global e-commerce platform might use a mesh to ensure fast data exchange between regional VNets hosting microservices. Now let's visualize steps that are required to create Azure Virtual Network Manager. So we'll go into more detail during the lab, but just kind of for you to visualize the steps that are required. First, we need to create a virtual network manager, or AVNM for short. We need to specify a name and the scope, that is it in just one subscription or goes across multiple Azure subscriptions. Then we define network groups, that is the container for the groups, for the container that VNets, we can then add VNets to it. And as we specified, either could be static, that is manually we add this, or dynamic. Again, we specify a name for it, specify the parent. The parent is the virtual manager that we specified here. Next, we'll define a connectivity configuration. We select a name for it, and then we specify is this a mesh or hub and spoke topology, and again the parent, which is that virtual network manager. Next, optionally, we can also define a security configuration, and then we deploy it, and then it goes through the process. It creates the virtual manager, it creates the group, and then start pulling in all the VNets that should be part of this. Then based on whatever topology we selected, it creates a topology for it, and basically that's how it's done. So to perform the lab, you need some prerequisite. The first one is you need an Azure subscription. If you're not an Azure subscriber already, you can get a trial version for a 30-day trial period. You can go to this URL and apply for it. You also need Bicep VS extension tools. So Bicep, again, is a domain-specific language for Microsoft in order to do infrastructure as a code for Azure. And then for the VPN gateway, you need some way of authenticating to the VPN gateway. There are a couple of ways you can do that. Either use client Entra ID, that is use Azure AD for authentication if you want to use that method, and that's the method that we are going to use for this lab. So this is the instruction of what you need to do. Or another option is use certificates, and then these are the steps that you need to take in order to set that up. And that is for authenticating from the client machine to the Azure gateway. And then you also need a VPN client app. Depending if you're on Windows or Mac, you can get either of those and download. For this lab, we will be creating 3 VNets, and these are the IP ranges for each VNet. Of course, we will be creating subnets in each one of those VNets. And then we create a network manager and also create a network group. And then we set up mesh topology for to connect all these 3 VNets. We'll also set up a VPN gateway on the first VNet, so in order for us to be able to get into the VNet and do some testing. So the structure of this lab is very similar to the previous lab. So we have a driver.sh. This is basically, we set some parameters from the command line and we send it to main in order to execute the script. And then we call the script here, which is AZ deployment group. And then we execute the main.bysip. So main sets the stage in order to call other modules to do various tasks, such as creating VMs or a VPN gateway or network manager and so on. So it's a good idea to break it up into different modules rather than having a huge script that does everything in it, because otherwise you can't reuse. And most of the stuff that I'm using, I'm doing demoing here, we actually created in the first video, and then we kind of reuse those. And that's a good way in order to reduce code and have kind of better manage your code, is to create these modules and then reuse them. So main is used in order to set the parameters that are needed in order to call other modules. And some of them, then we can set parameters in main. The parameters, they can have default values, for instance, the location. You can send it from the command line, or you can send it in here. That's what I'm doing. I'm sending it, I'm calling a function called resource group.location. This will give me the geographic location that the resource group was created in. And if you pass in from the command line, then overrides whatever the default value is. So if you want to override the default value that you set in main, you can override it and send it from the command line. I'll show you in that when we go back to driver.sh. And then principal ID. This is something new that we didn't have before in the previous video, because something changed between releasing these 2 videos. Going forward, in order to create VPN gateways, the user, whoever that user might be, either a person, even an admin, or a service account, then they need to have specific permission. So if you are an Azure Classic admin, you still need some new privileges in order to create VPN gateways. And we'll go through that when we call the function that actually, or the module that actually does that, gives that permission to myself actually. So we pass in the principal ID from the command line, and I'll show you how to get the principal ID of the person who's running the code. And then we set things such as a network manager name and so on. And like the previous example video, we define kind of the CIDR and subnet information for each VNet. So we set the CIDR IP address range for the VNet 1, and these are the subnets that will be created within that. Same thing for VNet 2, and the same thing for VNet 3. And then, like the previous video, we'll be creating some VMs, and we create 3 VMs that will be deployed in 3 VNets respectively. So we pass in the name of we'll create a We won't be using the username and password, rather we will be using the SSH public private key, and then as part of the driver.sh will create those keys, and then we pass in the names of those keys to the. These are needed when we create the VMs. We also set some names for our 3 VMs here. And then in the previous example, we did some testing with the network security group. So if you want to implement that, you set it through, and then I'll show you the function, the module that actually creates an NSG. And then, like the previous video, we set the IP range for the VPN client. So when the client connects to the VPN gateway, this is the IP range that I set. It could be different for your environment, so pay attention to this and set it accordingly. And then by default, gateway is set to false. However, from the command line, I set it to true. So during the testing, if you don't want to go through the overhead of create the gateway right away, they can set it to false. And then this is the module that sets the appropriate permission for the whoever is calling the scripts. And we'll go through the code a little bit later. And then this module, if you set it the NSG to true, it will call this module and set up the network security or the filtering or security for accessing one of the subnets within that. If you set it to false, it won't execute this. And then we create for each one of those VNets, for each, we create an array that encapsulates all the subnets in those, and then we set things such as the subnet name and the IP ranges for each one of those 3 VNets, exactly what we did the last time. And then they create a spoke VNet array, and that array will include the information about the VNet, such as its CIDR range, the name, and also it includes the array of subnets that belong to this. So this refers to this subnet VNets or arrays that we created earlier. And then we call the create spokes module, so it goes through a loop or sends the array of VNets to this module, and we went through that the last time. It basically creates the VNet. So once it's completed, then all the VNets, the free VNets, will be created. And the next one then is create VPN gateway. Again, we went through that the last time. It sets up the VPN gateway. And then we create an array of VMs that has the VPN information, such as the VM name and SSH key for that VM. And then we call a module called create VM. We go through the loop. We create a loop, an array here for each one of members of those arrays that contains the VM information. We'll go through that, and then we create the VM. So once this is completed, then all the 3 VMs will be created. And then this is where we actually create, it is new, so this is where we create the network manager, and we go through that in more detail in just a bit. We pass in some parameters such as the location and also the Vnet IDs. And then once we create that, although we've created the network manager, but we need to do another step, and that is committing the changes to Azure. And that's done through a script here, and we'll go through that script also. And that will finally then we create the the network manager. In the previous episode, we went over some of the modules that create VNets and VMs and VPN gateways. They are the same, nothing has changed. So I skip those and just go and we go over the ones that that are new and are needed for this topic. So the first one is we need to create roles or give permission to whoever using the scripts to be able to create VPN gateway. And in this module, and then the parameter, we pass in the principal ID or user ID of the user who's running the script. And then we create a resource, I call a role definition. And the type is Microsoft.authorization/role definitions. And then the version. And we select a unique name for this resource. It has to be unique. And then we use GUID. And we use a subscription ID and a string in order to make that unique. And the properties, we select a role name for it. And then under permissions, these actions are the permissions that the user will need. Some of them are related to virtual network subnets, like joining and writing, and some of them are for public IP address, join and write. So these are all necessary for the user to have. And then down below, we create a role up here. So there's no role directly created for this in one shot. So we create those as a user-defined role. You could use the network contributor role, but it's got too much power, too much permission that whoever is running this doesn't probably need it. But if you want to make it simpler, you could use rather than creating this custom role, you can use the built-in network contributor role. And down below here, we create another resource. This one for assignment, for assigning the principal ID to the role that we just created up there. And then the type is Microsoft.authorization/role assignment and the version. And again, we pick a unique name. And under properties, we have role definition ID, which is the role definition ID of the type that we created or the role that we created up there. And then the principal ID will be the principal ID that we passed in. And the principal type is user. So that once that runs, then it will assign those appropriate permissions that are up here. Those actions are granted to the user. Okay, the next module that we'll be looking at is the one that actually sets up Network Manager. So we're passing a number of parameters, such as Network Manager name, location, and an array that contains the VNets. And we will be using static membership, so that's why I use static and the VNet name and the group name in order to distinguish it from. In the future, we will be using, in the next video, we'll be using dynamic, and in addition to static groups as part of membership. So kind of distinguish between the dynamic and the static. We also select a name for the group name that will be created for those VNets as part of the process. And then the configuration name, and then app name. And also we need to create a user service account that will do the deployment. So again, once we create a network manager and we define it, it creates it, but it's not complete. It also needs to deploy a script that we'll be talking about that next. And then in order to deploy that script, it needs to have network contributor role. So we need to create a user that has that permission. So I select a name, MASH deployer. So that would be the name of the service account that will be created, and we'll take a look at it below. And also, this is the contributor role ID that we specify, and then this is the GUID of that role, and then we pass it into subscription resource ID, and then we pass in also the Microsoft authorization/role definition, and that will give us the resource ID of this GUID, so that role. So we need that later on. We also select a name for the resource software again to make that unique. We talked about that in the previous video. So the first thing that resource that we create is the network manager itself. So the type would be Microsoft.network/network manager, and this is again the version. And we call it network manager, the name of the resource. And then over here, under properties, network manager scope access, and then we specify connectivity. So you can either say this is a connectivity group or security group. So right now we are going to use connectivity because we're going to create a mesh. We are not doing any security settings for this, so we just leave it as connectivity. And under network manager scopes and the subscriptions, we specify the subscription ID. So because this is only within one subscription, so we only add one subscription. If it will go, the VNets go across different subscriptions, then we need to add other subscriptions that will be part of this. Next, we define a network group. So this is the resource. Again, we select a name. We call this Vnet static management group. And then the type is Microsoft.network/network managers/network groups. And the version, we select the name. Again, it has to be unique. And then the parent would be network manager. So this would be a child of network manager. So that's it. So that's basically they could create a container for that. And then within that, we have the child resource that adds actual members to it. And because we are using static members, we manually adding those to the group. So we loop through the array of VNets that we have. And then for each one of those, we add them to the group. And then next, we are going to create a configuration resource. So the type is Microsoft.network/network managers/connectivity configuration. And then select a name. And the parent again would be network manager. So all of this will be the child of the network manager as we described in the presentation section. And the properties, we have applies group, and then we pass in in this case, we only have one group, which are our VNets, static VNets. So we only have one array that is passed in here. We could have multiple of those. So group connectivity, we specify directly connected because this will be participating in a mesh. So they should be selected or specified directly connected. The other option is none. So if you don't want to don't be connected, then we specify none. Obviously, in this case, we want everything we connected because you're creating a mesh. A network group ID is the group ID, the ID of the VNet static manager group that we created earlier. So just pass in the ID of that. And this global is false because everything will be created in one region. And then the topology, we specify mesh. The other option, of course, is hub spoke and delete existing peering through. So if these VNets are already engaged in peering, it will automatically remove them, and then we create a new peering based on the spec that we are specifying here. And again, it's global false. And then next, we'll be creating a service account. So this service account is managed by Azure, so we don't have to worry about the password and managing that. It all maintains by Azure itself. So I specify a unique name for it and the location. So that will create a service account in that resource group for us. And the next, we assign we assign a role, which is the network contributor role, to that account that we just created. So role definition ID is the one that we created earlier. So that would be the network contributor role resource ID, and participate and principal ID would be the principal ID of this, and the principal type is service principal. So it's not regular user, it's not user, but service principal. So that will create or define a service manager, and then we output some of these settings, such as network group name, the user access identifier ID, connectivity configuration ID, network group ID, and so on. And those will be passed to the next module, which is deploy script. So this module deploys the network manager creation that we saw in the previous module, and it receives almost all the parameters that this one exported. So this will be exported to main, and main then call this deployment script and passes in all the required parameters. We also need to specify a config type. And in this case, it has to be only connectivity, because we are using connectivity creation. It's not a security deployment, so we specify connectivity rather than security. And then we create a resource deployment script. So this would be of Microsoft.resources/deployment script. And again, the name, location, and the kind would be Azure PowerShell. And then the identity will be a user assigned. So that would be the identity, the user that we created in the previous module. We pass it in, and then it would be using that. So that user will be executing or will be deploying this on our behalf. And then it specifies the PowerShell version and so on. So, and then we on the fly creates a PowerShell script, and the arguments that are passed in kind of mimics what we pass into the module itself, which is a network manager name. Target locations will be which locations it will be deploying to. In our case, it won't be a global or multi-region, it will be only one region, so that would be the location that we passed in, and so on. So it uses everything else that we passed in, and then it creates this PowerShell script, and over here it creates an argument list, name equal to network manager name, and resource group. We pass in the resource group, or the resource group that will be created as part of this process, and passed in the name of it, configuration ID, and target location, again the location. So all the Arguments are bundled in as a kind of argument list and then passed into this script or function, which is called deploy/Azure network commit. And then it passes in this bundle, this argument list. And this is how the commitment occurs through this deploy-Azure network manager commit and the argument list. Okay, let's go back now to the driver and actually execute our script. So the first thing that we need to do is we need to create a resource group on line 10. Let's go ahead and execute that. That will create a resource group, which is the container for our deployment. And that is created. Now, the next we need to create some SSH key for the VMs that we'll be creating so we can log into those VMs. So the statement itself is actually here. So this will create, so AZ SSH key, create -- name. So we use SSH key VM1 name for the first one and which resource group. But we'll be using these statements here to kind of as a helper, because once this is executed, then Azure will create the SSH key and then we'll copy them into the SSH folder on our machine. So, but these are random key and we don't really know their name. We want to capture those names because later on in the script, you're going to SSH into those VMs, or at least one of the VMs. So we need to capture the name of those VMs. So this is how we do it. We capture the name before we execute it. In this case, the directory was empty, so there's nothing in it. Then we execute this. So it's going to create the first key. And then if we go now to the SSH folder, we'll see that it created two files. This one is the public key, this one is the private key. And then next line, we kind of check to see what's new. So we compare it to what we had and then what's added. So now this will have the names of the newly created folder in the file in that directory. And then finally, we extract the name. So we looked at, there are two of them. So this one has a .pop, so we're going to use that name. We stripped out the .pop and then we capture the name. So this one now has the key name, the key file name for the first VM. And we do the same thing for the second and third VM. You're going to create private public key pairs. And then let's go ahead and execute those. So we go back to this folder here. Now we'll see I have 6 of them. So 3 private key and 3 public keys. And we can verify them. So these are the name of the file, the private file key that we need to use for authentication. Okay, now that we have that kind of figured out, now the next is to actually create the deployment. So AZ deployment, create group, create, and then we specify the resource group that we will be using this. We specify a name for our deployment, and then we're going to call the base, so that would be the temp file, the template file, and we pass in some parameters, such as create gateway, we set it to true. Set up NSG rule false, we are not going to deal with NSGs in this demo. and then we pass in the keys for VM1, VM2, the SSH key file name for the 3 VMs. And also we pass in the principal ID. So this is how we get the principal ID of the user who's logged in. So AD sign -in user show, and then -- query ID. So you extract the ID from the results and uses that to pass in to the module. So we're going to execute this. So this is going to take actually quite a long time, maybe a half hour, maybe more, depending on what region you're deploying to. So be patient, and we will continue once this is completed. Okay, the execution is completed now. Let's go ahead and take a look at Azure and look at the artifacts that were created. So these are the stuff that we kind of created as part of this. This is a deployment script, and this is the identity manager and network manager, and then the rest of them are network interfaces and so on. What we are interested is this network manager, because this is new. And then you can take a look at some of the properties that it has, some settings, and then network groups, what groups are part of that, and then this is the group that we created. So if you click on that, we'll see that the members, group members, we see that these are the 3 members that were added. And then the source, it says, is manually added because these are static members. We manually added them. These are not dynamic members. So let's go back and maybe take a look at configuration. So this is the configuration that we created. And then I call it mesh, and then the connectivity type is mesh. And deployment, this is the deployment that we created. So basically, this is what you get when you deploy this. And we only deployed it to one region, so it's not global. So let's go back to Visual Studio Code now and do some validation to make sure we can get to those VMs, and so do some testing. So let's go ahead and grab all the IPs of the VM, the IP address of the VMs, and also the name of the VPN gateway that we created. So let's go ahead and run that. So these are the 3 IP addresses of the 3 VMs. And also the last one is the name of our VPN gateway. Next, we are going to download the client configuration and the VPN gateway client configuration, because we need that. So we run a bunch of commands that I talked about in the previous episodes. I'm not going to spend any time on that. Let's go ahead and run that. Basically just contacts the VPN gateway and gets the client configuration. It takes a minute or so to do that. Okay, now that it downloaded that, let's go ahead and just go to there's a VPN client. So we need to reference that config that was just downloaded, and I copy it here. Just open that, and then we saved it. Let's go ahead and save that. And then we click on connect. Not going to, because you are using Azure AD, authentication is going to ask me to put in my email address, and once it will send a notification to my phone, to the authenticator, Microsoft Authenticator on my cell phone, and then I need to authenticate, and then I'll do that, and then we'll come back when that's completed. Okay, that's completed, and as you can see, this is now green. Let's go back to our Visual Studio Code. And now we define an alias, I call it SSH VM1. Basically, we create an alias, which is, the command is SSH-I, and then I specify the SSH key file that I'm going to use, and the name of the user, and the IP address of the VM. So we're going to SSH into, through this command, we'll SSH into the VM on Vnet 1. And then we're going to kind of test connectivity. We're going to ping from VM. Also going to reuse that SSH VM1. And we're going to add this command ping -C3 and then the IP address of the VM2. So we're going to basically make sure that we can connect from Vnet 1 to Vnet 2. And then because it's the first time you're going to connect, I say yes. So it will add that to the SSH. Okay, and then we see that it was successful. So let's go ahead and run that again. And it's going to, this time because we already added to SSH, it's not going to ask us again. So this is the result. So we can ping from a VM on Vnet 1 to a VM on Vnet 2. Let's go ahead and do the same thing. We can then, now we want to ping a VM on Vnet 2 from a Vnet on a VM on Vnet 1. So let's go ahead and execute that. You'll see that is the result of, okay, so we can connect. So it kind of proves that these are, because we created the mesh, so all these VNets are connected and everything can be connected. Now we could do further testing. I mean, you can do from one VM, from VM2, connect to or ping via VM2 and so on. Because we're only using one VPN, so we can only be VPN to Vnet 1. If you want to VPN, you want to go further than that and then actually SSH from VM1 to VM2, then you can use this command here. Basically, copy the SSH key to the VM on Vnet 1, and then we can SSH. We did that the last time, so you can go ahead if you want to kind of verify on your own, make sure that you are able to do that. Oh, let's go ahead and actually do it. So let's go ahead and copy the key to VM1. Then I'm going to adjust the security on those, because on Windows it adds a lot of security that we don't need, and that Linux require a kind of more lockdown access. So once we copy it over to the VM, we're going to lock it down more. So we're going to actually not physically SSH into VM1. So we are now inside the Vnet, VM on Vnet 1, and this is called VM1-spoke1-Cosmo, and the name of it. So this is basically, we are inside now the VM1 on Vnet 1. Now we are going to SSH-I, and then you're going to SSH to a VM on the other Vnet. Let's go ahead and do that. And then, because this is the first time you're going to connect SSH from this VM to the other VNet, we say yes. And now we'll see that now we are on the second VNet VM on VNet 2. And you can do the same thing. You can, and then VNet, or you can SSH from this VM to a VM on VNet. So just kind of, you want to satisfy yourself to make sure that everything is connected. So this is how you test it. But rest assured, when you create a mesh topology, all these VNets are created by default, are connected by default. Okay, so that's it for this video, and hopefully we'll continue on our Azure journey in upcoming weeks.